Hey, how's it going everyone? Welcome to this video. This is the last video of this section. We're just having a look at example 13. So the first question is identifying the symmetrical points to 20 degrees and which of these points is the same, or is the tangent value the same as tan 20. So the first thing we need to look at is the first bit of information. So using our unit circle, 20 degrees, I'll say roughly is something like that. Well, that has the symmetry properties as a reflection across the vertical, and that's going to be 180 minus 20 gives you 160 degrees. And that's going to be the same as this symmetry across the horizontal, which is going to be 180 plus 20. So we get 200 degrees. And then the last one is finding by taking 360, take 20. So we get 340. So that's the first bit of information. Sine of 20 degrees has symmetry points at 160, 200, and 340 degrees. Which of the tan values is the same as tan 20? Well, tan of 20 degrees, tan is positive in the first quadrant, and tan is also a STC. Tan is also positive in the third quadrant. So tan of 20 is exactly the same as tan as 200. So the tan value at the trig point 200 degrees has the same value as tan of 20. Second bit of information, or second question, express sine of 6 pi on 5. 6 pi on 5 in terms of the first quadrant value. So if we draw up another unit circle, 6 pi on 5, well, here's pi. 6 pi on 5 is the same as 6/5 over pi, which is 1 and 1/5. So we have 1 full 1 plus pi on 5. So sine of 6 pi on 5 is going to be sine of pi on 5. And we're in the third quadrant, which means tan is positive, so sine is going to be negative. So sine of 6 pi on 5 is going to be the same as minus sine of pi on 5. And that's all I need to do at this stage. Part C, if cos of theta equals 0.6, give the values of cos of pi take theta and cos of 2 pi take theta. So pi take theta is pi, and pi take an angle will give us the second quadrant. So pi take an angle is in Q2. So I can say cos of pi take theta is going to be the same as cos of theta, but it's going to be negative because I'm in the second quadrant where sine is positive. We know that cos of theta is 0.6, so therefore we can say cos of pi take theta is minus 0.6. Cos of 2 pi take theta. Well, here's 2 pi. If we take away an angle, we get 2 pi take theta over here. So that's in Q4. And Q4 has positives for cos. So I can say cos of 2 pi take theta is going to be the same as cos theta. And we know that cos of theta is 0.6, so it's just 0.6. And last couple of questions, we've got tan of 7 pi over 6. I want to work out the exact value. So tan of 7 pi on 6, well, that's the same as tan of 7 over 6 pi. Tan of 1 and 1/6 of pi, which I can say as pi plus pi on 6. So here's pi. I've got pi plus pi on 6. So it's pi plus theta, where my angle is pi on 6. We're in the third quadrant. Tan is positive, so tan of pi plus theta is going to be the same as tan of theta, because we're in the third quadrant. So therefore I can say tan of 7 pi on 6 is going to be the same as tan of pi on 6. Tan of pi on 6 using our exact values is 1 over root 3 or root 3 on 3, either one. So that's my solutions for tan of 7 pi on 6. And the very last one, I'm out of room here, so I'm just going to start a new page. We've got sine of 11 pi on 3. 11 pi over 3 is the same as 11 on 3 pi, which is 3 and 2/3 pi. So here's 1 pi, here's 2 pi, so 1, 2, 3 plus 2/3, so an extra third, so over here in the fourth quadrant. So we're in Q4, which means I can make this triangle here as 2 pi take pi on 3. And I want the sine of that. So that's 2 pi take theta. So sine of 2 pi take theta is going to be the same as sine of theta, except we're in the fourth quadrant and sine is negative in the fourth quadrant. So sine of 2 pi take pi on 3 is the same as minus sine of pi on 3. And pi on 3 is square root of 3 over 2, except it's negative because we're in the fourth quadrant. So my final answer, sine of 11 pi on 3 is simply the minus root 3 over 2. So that's all for chapter 9.5. Thanks for watching.